All right, we just submitted our animation assignments, which is our last compositing assignment. Doesn't mean we're not going to go back to pixels and using layers with pixels in the future, but we are making a big shift right before our midterm and going to Unit 9, where we're going to learn how to make the other type of popular two-dimensional digital image other than pixel-based raster images, and that is vector imaging. So I made this banner when we were in lockdown, right? And I thought this was really clever. These are not my designs, but I just made the banner of a few found designs from different designers. It was a competition to change logo designs to reflect the coronavirus and lockdown, right? And maybe the funniest is the Corona beer just changed to a new name extra. The Olympics, which were going on in 2020, had to be postponed, right? Where the rings are usually connected, the rings are socially distanced, right? Instead of LinkedIn, it's locked in, and MasterCard, similar to the Olympic rings, are usually overlapping, right? Touching, they're socially distanced. Yeah, probably. Just as a powerful image. Now, I use these because these are examples of modifications to existing logos, right? And it shows you how powerful a logo can be, where just by separating those rings, we understand what it's symbolizing, right? Logos are about simplicity and about kind of direct communication of sometimes very complex ideas. We have a lot in this unit because it's introducing us to vectors. First in this unit is a question of the day, which is due next week on October 14th. And this question of the day is something I want you to think about between now and next class and write down your thoughts for. It's what advantages does vector-based imagery have over raster-based imagery? And when you see raster or you see bitmap, those are names for pixel-based images. Right? Bitmap is the older name, raster is the now preferred name. But that means that it's made out of pixels, and pixels are squares. That's why it's not dots per inch, it's pixels per inch. So what's the problem with squares? Well, if you make something as a tiling of little squares, right? If you ever want a curve, like a circle, you have to make that curve out of squares. And so the smoother you want that curve, the more squares you have to use. That's where screen resolution comes from. So standard minimum screen resolution is what? Well, we can say any physical dimension, right? So we got 8 by 10 in general. 72. 72 what? Pixels per inch. So you notice this circle, which is showing at 72 by 72 pixels. Think of this as 1 inch, right? That's when we can see it as a clean circle, even though it's made up of squares. As soon as we get less than 72, which is standard minimum screen resolution, which means you should never produce anything that's less than 72 pixels per inch, because it's trash, we start to see those squares very clearly, right? So how do you make a cleaner image? Well, then you just increase your number of squares, but beyond screen, because we're projecting this on a screen right now, it doesn't get any better than 72 by 72 on most devices, unless you have high-def screens, things like that. So even as you increase the resolution, notice that the circle doesn't look any cleaner. But what it does do is mean that you can zoom in on that circle and it will remain clean. But it requires a different file with a different amount of pixels with a different amount of memory each time. And that's a pain for a lot of practical reasons when you're doing commercial imagery, right? So here's an example, a real life example. I do a fair amount of t-shirt design. A lot of the t-shirt design I do are for campus committees or for local bands or for just promoting a single product. I've done things for like stunt sportswear. And these t-shirt designs are always meant to be pretty cheap t-shirts, right? And the easiest way to get a cheap t-shirt is to only have it be a one-color ink. Because the more colors you have, the more times it has to run through the silk screen And that's a lot of labor cost. So a one-color t-shirt design is usually based on line art, right? And line art is like this circle. It has straights, it has curves, it has thick, it has thin, it might have lots of little details. And you can save that as a high-resolution raster file. You can save it at 600 pixels per inch at the size that it goes on the t-shirt. But no matter how high your resolution, it will never be as clean as if you just drew that shape as a vector. So you can see the difference between a low-resolution raster, which looks terrible, a high-resolution raster. Anything higher than 300 dpi is considered high, because 300, not dpi, should be ppi. 300 ppi is the standard print resolution, right? But vectors are going to be clean at any scale, no matter how big. They're always going to be perfectly smooth. So, if you click on this link in this question of the day, this is what I want you to look over and try to understand between now and when we're working on our vector projects on Monday. These slides are all about the difference between vectors and raster, and I start with a video made by one of my very first digital honor students. Remember, digital honor students take the class a second time to build a personal portfolio. This was back in 2011. And this student was unusual for one of my digital imaging students in that they liked vector imaging more than raster imaging already when they came into my class the first time. They had been introduced to vector imaging in high school, and they just really loved it. So they asked if they could make this their mentorship presentation, and they decided to do it all as a vector-based animation, which back in 2011 meant we used a program called Adobe Flash, which I used to teach, because it's a vector-based animation program. We no longer do Adobe Flash because it's not supported by phones or tablets, right? And if you want to do vector-based animation like the TV show Archer does, like South Park does, there are lots of vector-based animations out there, but it's not something that is consumer-friendly because processing speeds on computers are so fast now that it's just easier to do it as raster. Except there are custom programs that can do both. So, this was back in 2011, which explains why he calls raster images, pixel-based images, bitmaps, which is an old term for them. But when he's talking about bitmaps, he's talking about pixel-based. So I'm just going to play it because he did a nice job.
Bitmaps versus vector graphics. Bitmaps are a collection or an array of bits, which are also known as pixels. Up until now, this is likely the only kind of graphic you've ever worked with. However, there is another. Vector graphics are paths which are plotted through mathematical algorithms. The method of using these algorithms was spearheaded by a man named Pierre Bézier. Pierre was a French engineer, and he had an idea. He came up with a way of using de Castelju's algorithms to plot any curve between two or more points, and those curves could in turn be used for any number of industrial applications. He was a leading influence on how CAD and CAM machines work and how 3D models are created, and it's all beside the point. Because vectors are processed in this way, they don't store a finite number of pixels and can be scaled to an infinite size with no pixelation. This means they can be used for something as small as, say, a stamp, to a package like a bottle, to a poster, all the way up to a planet-sized billboard, and you can do it all from the same file. So what does all of this actually mean? Why do we still use bitmaps? Isn't vector just far superior to raster in every way? Well, it is and it isn't. See, vectors and bitmaps are good at different things. Vectors are good at making clean, simple shapes which usually use a limited color palette. They're also perfect for images that need to be scaled, either larger or smaller. Bitmaps, on the other hand, are good at details, usually things like color shifts. They're also far better for sub-48 pixel designs like desktop icons. Bitmaps are also how photographs and scans are stored, since it's impossible to capture an image as a vector. For example, sometimes you need a complex image. Digital paintings can only work as bitmaps because in a bitmap you have full control over each pixel. Vectors can only store a few pieces of information about the contents of a path. One is the stroke or the outline. The second is the fill, which is the color or the color gradient which is placed inside the path. when you create vector graphics, you're basically accomplishing your goal by doing one of three things: manipulating the stroke, fill, or the shape of the path itself. So you may be asking right about now, if vectors are based on algorithms, does that mean that I have to do math to use them? Well, thanks to Pierre, the answer is no. Manipulating vector shapes is easy and completely math-free. There's also brush and pencil tools which can turn natural strokes into vector shapes. Also, just like in a bitmap program, you can use layers and layer groups with vectors. But these are just the basics, so take time to experiment with these programs and learn for yourself.
All right, if we get to this part, which is the key art for the video, this is basically getting to that question of the day of 3. What are the advantages of vectors over raster images? When is there an advantage? And it's when you want to have something that's clean, usually based on simple shapes, clarity like line art, logos, limited color. That's the big one. Since vectors can only fill a path with a solid color, that's their default state, like you did for your emoji exercise 2, you don't want to do photorealistic images with vectors. They're especially bad at gradients. There are ways to build them in, but that's not the ideal use of them. Their main advantage is that they are scalable. From one file, you would use that same line art that you make for a t-shirt to make a big poster, to make a billboard, to make the side of a semi-truck, to make a skyscraper, banner. It all comes from the same file. It's just way more efficient with its memory. Raster images, pixel-based images, bitmap images are good for really minute details, gradations, which this student calls color shifts, and for certain really small images, it's actually more efficient to use pixels than it is to use vectors, like desktop icons. And then he makes this point, which is a really important point that students have a hard time understanding. When you take a digital photo with your phone, it always translates what the camera senses into pixels. When you scan something into a computer, it can only translate what you scan into pixels. When you photocopy something, it can only take what you photocopy and input it as pixel data. There is no way to capture a vector. Vectors have to be created. Okay? And we will learn how you can vectorize, or what's called image trace, a pixel-based image into a vector, but then you have to really modify it yourself, because vectors always have to be created. So this is my summary of that. Right? They're ideal for simple color shapes with hard edges. And then the way you use them is you treat each shape as separate cutouts that you can layer on top of each other. So you can get quite a bit of complexity that way. So here's a little My Little Pony illustration. This is done with pixels. This is done with vectors. And though the resolution is a little low to emphasize the point, this use, making it with vectors, makes it way more practically useful. You can use it for way more reasons, all from one file. And so it really works well with just what's called flat color and line art. Really good for illustration. So if we look at, video game design and character design, they all started as pixel designs because the programs were so limited, 8-bit, 16-bit, 32-bit, right, that they couldn't even support vector memory. So we are creating characters like Mario and Donkey Kong out of 8-bit pixels. This is like 8-bit style. So the fewest number of squares. But notice each square really gives definition to the shape of the character. Times have changed, and as processing for imaging has improved, we have vector-based characters. So now Mario, I believe this one is from Paper Mario, it's still a 2D character, but it's all created with vectors. So that same file for the character can grow bigger on screen, can be made smaller on screen, will always be perfectly clean because it's not pixel-based. And you will notice there are some gradients in here. You can build gradients into vectors, but they first have to be filled flat, and then you have to put a code on top of them that turns the flat into a gradient. So it shows how complex these vectors get. What's so great about vectors as well is it's the same technology for making vectors in 3 dimensions, which are 3D models. So now a lot of the time, even if you have a 2D design for a video game, say, or for a 3D feature film,